Hello, ladies and gentlemen. Welcome to Learning CAD. This is a collaboration between the Northwestern Formula and Baja teams, and we're super psyched to get you guys started learning CAD. We're going to start off with Unit 1, Part A, which is going to be the what and the why of CAD. Before we get to that, though, let's just do a little course outline. These videos were meant to be a supplement to the things that we are teaching you in person, but don't think that you need to be watching all of these videos at once or that you need to be watching all the videos at all. Instead, you can come back to these videos as needed and use them as a resource that you can bank on when times get tough. The videos are all short. We're aiming for 5 minutes or less for each video. And as always, with anything on the card teams, ask for help if you need it. It always turns out better that way. Before we move on any further, let's just introduce ourselves. My name is Cam, up here in the top right corner. I am a senior, and I'm the technical lead on the Baja team. And helping me with this project is Sarah Young. She is a sophomore, and she's Formula's Aero lead. You guys are in good hands, so let's move forward. Okay, so what is CAD? Fortunately, unlike what Google has to say, CAD to me is not a man who behaves dishonorably. Instead, it stands for Computer Aided Design. So that's pretty understandable outright, but let's try to dive deeper a little bit. To some, at maybe a high level, CAD is an art form. It's a method of creating things, just like other methods of creating things, like sculpture or pencil and pad or paintbrush and canvas, all methods of creating things. To other people, CAD is kind of a science. It's the application of rigorous scientific precision to the art of making 2D and 3D things. But to us, to you and me as engineers, we mainly think of it as a tool. And a tool for many different things, like communicating with each other and understanding ideas. Well, we're going to dive into that next. So now we know what CAD is. Why should we use CAD? So there's many different reasons. I've listed three really common ones in a car team context here, but there's 1,000 reasons. So firstly, we can do analysis with CAD. So we can basically ask the computer to simulate for us, hey, computer, what if I put 1,000 pounds of force on this part right here? Is it going to break? Or computer, if my part is subjected to 800-degree heat, will it melt? Right, things like that can help us make design decisions without having to go and apply 1,000 pounds of force in real life. We can just do the testing on the computer. Another great reason is understanding if our ideas will actually work and if they'll fit together. Will the parts that we are going to make accomplish the goal that we have for them? And then lastly, probably the most important thing, and the reason that we primarily use CAD on the car teams is so we can manufacture stuff. Because in order to manufacture something well, you need to have a really precise and really repeatable idea of what that part is. And CAD basically just is a system for collectively understanding what a part is. Okay, so now that we've talked about CAD at a high level, I just kind of want to ground this discussion before we end and mention that CAD is ultimately a blanket term for applications that let you design stuff on a computer. So on the car teams, we use a program called SolidWorks. Other classes at Northwestern use NX. The best free one is called Onshape, and then there's some other ones that I've listed that you might see in the future, just so you know, oh, that's a CAD program. If you've used one, you can kind of use all of them. It's a little bit like programming languages. But yeah, we're going to be using SolidWorks, and we're going to get into that a couple of videos from now. This has been part one. I'll catch you guys in the next part. See ya.